interface for patient ventilation interaction analysis in the breath. Let's choose one of the patients that was ventilated 27 hours. I would not repeat opportunity to see monitoring parameters and other things. We immediately will see statistics about modes of ventilation. We see that it was 2 modes, adaptive support ventilation and volume control, and statistics about patient ventilation interactions. We see in one chart all the information about all kind of asynchronous cycles according to the whole time of ventilation. We see that in the very beginning it was a lot of late cycling in ASV mode, and later in volume control it was periodical workshift, quite severe flow hunger. What is very important, we don't need to believe that it was correct. We can check it by zooming in, as always it was possible in the breath. We just zoom in to less than 5 minutes period, and we see a review that really there were late cycling asynchronous, and they were quite frequent, so almost each breath asynchronous. We can zoom out and zoom in another period to see another kind of asynchronous. I want to keep in mind that currently I'm on my M1 laptop, so it's not huge server or something else, and I am from mobile internet connection, so this performance is possible. So we see that between normal ventilation episodes, so it's like a purple color, we see some episodes with quite severe workshift of patients, so patient try to inhale here, and so even pressure goes below 0 during inhalation period, and then it stops, and then it repeats again with some yes, it works. So we see that it's fine, and now it's again, and we see that accuracy is quite high. So really so for example, this is ineffective fourth cycle detected by the breath. This is late triggering, so we see that patient triggers here, and only then ventilator start their support, and this is again workshift. So we see very good quality of automated patient ventilation interactions classification, and very easy we can review all of this, and if it would be in real time, and in current implementation of DBRES, it happens in real time. So here is current interface. It's simulation, but the same will be for any connected ventilator. We see it's these kind of statistics in real time, and each breath classified, and we see what happens here and can make adjustments if needed. So that's how DBRES works, and that's how we would like you to use it for your research, for your clinical work, for education and other purpose. Easiest cases for patient ventilation interaction classification. So it was 8 hours, but there were several periods of quite high amount of failed triggering, late triggering, and late cycling. In the end, we can check for the beginning, so that there were really effective fourth cycles, and they really were very classical, how in like any research paper about asynchronous cycles. So I think it's around 100% accuracy of detection, and this is late triggering. So we see that patient started inhaling, and only later ventilator reacted and tried to help. And also what is interesting and important, that also, let's check this moment of time, so about late cycling. So we see it's almost 100% of late cycling here. So at the moment of maximum pressure, flow is already negative. So patient started exhaling much earlier than ventilator stopped its inhale. And what is interesting is that there was no alarm during this period of time. So it's alarms from ventilator. So we see pressure, we see inspiration tidal volume. It was short period with like 32 alarms. Minute volume was fine. Respiratory rate, everything is perfect. But there were many asynchronous for around 1 hour. For example, this failed triggering cycle, and we also can see, for example, how respiratory rate that it was reduced during failed triggering episode, and it's quite obvious because patient wanted to inhale, to breathe more frequent, and its ventilator didn't support it. So this kind of analysis can be done now very easy, almost automatically, and we sure it can be very helpful in your research. Detection of patient ventilation asynchronous. Patient was ventilated 18 hours, but there were different types of asynchronous during ventilation. Now I would like to show example of early triggering or reverse triggering, depending on how you call it. So we can zoom into a specific period and to ask to show waveforms. As always, we need to zoom into less than 5 minutes, and that is the case. So it's reverse triggering led to double triggering, and with pink it's highlighted reverse triggering cycles, and here they are detected quite well. Ineffective effort, failed trigger, and later we see that they led to multiple triggering. Let's also zoom in this period to see what was happening during this time, and yeah, we see that there were different types of, also it's reverse triggering, and later they led to double triggering, and it was quite frequent here. So we also see like an effective effort, and we see reverse triggering led to double triggering, and it's quite frequent here. So that's how DBRES can allow to detect this. We see the full statistics of the frequency of these asynchronous. We see how many of them, how frequent they are, and again, if it's in real time, of course it can be prevented, and I hope it will be done in future. Most challenging thing during training of DBRES algorithm, and I'm really proud now that we achieved these results. So this patient from control data sets on non-single breath from the whole 45 hours of the ventilations were in trained data set, so it's absolutely clear experiment. And so I would like to. So we see that in general ventilators work quite well. Only in the end there were like failed triggering and late triggering cycles, around 10%. And as always, we can see how detection was good or not, and we see that detection is quite well. And what are the most challenging thing, that there were a lot of cardiac oscillation also during this period, and it was very hard to tell algorithm that like this is patient effort to breathe, because it's in more details we see that it's a harder attempt to breathe, and this is just regular cardiac oscillation, so it's not attempt to breathe, and that was really difficult, and we're really proud that currently we don't provide false positive because of cardiac oscillations in information, but we still detect both late triggering and failed triggering cycles even in heart condition, and we hope it will help to improve treatment.